exams. Dang. So that whole start early thing didn't work out?
Nope.
It's alright. It should only take like 45 minutes to finish. Tops.
That's exciting.
Yeah. So we should all be set. So, yeah. As I tried to understand the spec for 45 minutes, I thought, so let's see. Last week we did type checking, kind of, right? We did kind of a hand wavy. Here's something you could do, right? I'm gonna, as you may or may not have noticed, I'm gonna do easy stuff all the time, and then let you guys do hard things later. It's more fun for me that way. So today I want to get into symbol tables a little bit, which is good because you'll hopefully be using them. Who remembers what our kind of choices are with a symbol table, or what a symbol table is? Maybe we should do that first. What do we want in our symbol table? We want it to be some sort of structure, right, that has things in it. What might those things be? Someone yell something out. Variables. What do you mean by variables? Okay. So variable names of some sort? That's good. We'll need that, right? There's really no way around that one. Type. That's good. Type would be perfect. Anything else? Scope. Scope is a really good idea, but we're probably going to implement it slightly differently. So what we'll do is instead of having scope be attached to each variable, we'll actually have two different symbol tables. C minus minus is nice enough to us that there are only in there. We could kind of attach a scope to each variable and then only have one symbol table and through, but it would make things really difficult when you wanted to, say, like remove the local scope. Any other ideas, or is this good? Data. Like the value? Good. So that's the last thing that I really see as important. We want to know what those variables are, right? The variable names could be, you know, just a char star, right, of some sort. You just have a list of characters, right? You could do a char star, you could say in there double and in a float, and then do and then over kind of table it. And then one, yeah. Depends. Oh, yeah. Awesome. pointer to a struct symbol entry. And you just have a let's call it table, I guess. Right, that wraps around right to left. I didn't have to write struct symbol entry. Isn't that great? Saved a whole 5 characters. And a space, which is important to note. I like that. Okay, so what do we need now? We have a allocate memory. Yes, we will need to allocate memory. When do we want to allocate memory? Do we want to allocate 1,000 symbol entries right now and go back to my first original awful idea? Probably not. Allocate them as we create them. I like that idea. It's a good one. So we'll do that. So as we need to put more entries into our symbol table, we'll allocate a new symbol entry struct. So are we done? Like, are we ready to go to the yak now and just put this in our rule? Insert operation. Good. So we could just go straight to our yak rule, and every time we want to insert, we could write the same code over and over, and every time I want to look up, we could write the same code, and we could copy paste. Or we could be modular programmers and write some functions, right? So the 2 things that I imagine we need are get and add, right? Other than that, I mean, you can pretty much use. Yes. So this small little example I'm making has no scope, right? But what you might do, you have plenty of choices, but you could have so when you enter local scope, you allocate that one, right, and start adding to that instead. And then when you leave local scope, you'll deallocate all that and set that pointer to null. One way you can do it. It's essentially like we've kind of predefined the stack, right? You could actually make a stack. It would be more robust for extensions to the language, but something like that would probably be enough. So, but now that I've said that, let's ignore scope. So just quickly so we know our target, I suppose. Our yak is going to be something in a declaration list. So all your declarations have to happen before all your expressions. Expressions are going to be, you're going to have to keep doing expressions as time goes on, and declaration list, new line separated, let's say, double x, double y, double variable name, you know. So that's what we're going for eventually. So we need add and get. You might be thinking ahead and be like, well, we might want to have check, right? Like check that this exists. Maybe we're doing a, you know, we want to make sure that when they do x plus y, that both x and y have been defined. We could write a function for that, and that'd be fine. Or if we just use get, right? And we'll have get return null or something, right? If it couldn't find it. In the case that our get symbol entry returns null, we'll be like, oh, well, that didn't exist, right? So we don't necessarily need that. So do you guys want to do add or get first? Yes, you would need to add a symbol before you could get any symbol, but that doesn't necessarily change the order we write them in. Okay, Brian wants to add first in case we want to test it alone, which is good. I don't know. I mean, it'd be kind of hard to test without a get as well, but we'll go for it anyway. I don't. Maybe some sort of GDB access to the struct. I don't know. Get would be much easier to code. But I did hear add first, so we're going with add. My golly. Already got my brain ready. I actually wrote down add first, so this is good. All right. So we have our symbol table, and I'm going to erase this because I want to stop going right to left. Anyway, pretend that's been defined. Right. So we have an add symbol. So what might the function header prototype signature type thing look like? Keith? Cool coin. Huh?
Let's call it
Add. Okay, so we'll call it add. I'll say our return type will be symbol entry pointer. Good. Huh? Okay, so we probably want parenthesis here, right? What might our parameters be for an add symbol? Keith?
symbol table entry star table.
Symbol entry star table. So you're adding to which table? Right? Right. So Keith is saying that maybe we should have our first parameter be a pointer to the symbol table, essentially. So which symbol table are we adding to? Which is not a bad idea at all, but for now it's too complex, right? I don't want to think about that. We only have one symbol table. We'll just assume that we're going to add to that.
Char star ID.
Double value. I like it. I like it a lot. Double value. All right. So we have our sloping up declaration, which is very uncommon for me. Can't believe that happened. All right. So first of all, we're probably going to need, I'll start us off. I'm going to name my variable pointer because it is a pointer. Now, we talked earlier about when do we allocate a new symbol entry. Now is a fantastic time. Very good. So we might want to say pointer equals malloc of size of symbol entry that's right. I think that's all the memory I need. Yep. We sure do. Oh, you don't? I thought you did, and I thought I made a mistake. All right. Okay, so we could cast this as a void pointer, but apparently C is just as smart as we are. Okay. So the question is, are we assuming that the variable is not in the table? By the time we get into add, should we check, right? And we'll say that we will check in the YAC. So when we're about to add a symbol, we will first make sure that it's null, and then we'll add. So by the time we've called add, our precondition is that the variable is not already in the symbol table. Does that make sense? I used a lot of words there. Brian?
Would it be less code like in our YAC file if we put that in the add? Because we only have to write one line instead of two for all those entries.
So the question is, would it be less code overall, right? Would we get more kind of code reuse if we actually did check in here the add? The reason I'm going to say no, and this is guesswork and hopefully remembering things, is because we need to check in our YAC file one way or the other. Well, okay, so you could construct it, I suppose. So you could check in here, and if it already exists, you could return a pointer to it, right?
Okay.
The way that I've kind of constructed the yak in my head is we say if you know, get symbol, then we, let's say, I don't know, do something like return that symbol, right? And otherwise, this was null, it wasn't found, then we need to add the symbol, right? So that's kind of how I thought of it in my head. Probably add all of that in this code. So let's go ahead and continue with what my notes say, but I think putting everything in here would work. So we've malloc, and then, right, so we still have one more piece we need to malloc, which is the symbol name, right? So we're going to say pointer name equals malloc, size of ID, I think. Does that make sense? Yes. We may be off by one here if we want to add like the null terminator. Let me ignore that for now and just say that C is going to magically take care of that for me. But we may need to add the null terminator to that. Does everyone know what that is? I'm sorry. It's kind of assumed, right? Everyone knows that strings have to end in backslash right. So let's say that we want to finish up with name first. That's the next thing that we want to do. Right. So we want to add those into the struct somehow.
There's actually a function in string.h called str_do, which will automatically malloc the size of the char star that you pass in, and then also copy all the values over, and then just return a pointer for you. So you can just complete that whole thing by doing str_do within the ID.
Okay, so for everyone who may not have heard in the internet, there's apparently a function in C called strdup, S-T-R-D-U-P, that will malloc for us and return the pointer and finish our project for us all in one. Let's assume we're not using strdup because that sounds incredible and ruins all the fun. So anyway, I wanted to hilariously point out something that I did for years before I got over it, because I come from a C++ world, which has a couple of really nice things about it. It's kind of in that Java realm, right? So my next stage would be like, well, I want that ID to be pointer name, so pointer name equals ID. Hooray, everything works, right? And I'd go along. It's worse than that, actually. Yeah, that's the problem. So I'm like, all right, well, pointer name, I want that to be ID. I assume that C will take care of that, like any reasonable language would. And it's like, well, you want to assign one pointer to another pointer? Okay, right? So it assigns the pointer to ID. ID is going to run out of scope really soon. And then pointer name is going to point to nothing. Project lines long and seg faulting. So we have to do string copy, which these two stages could be done with a strdup. What does the dup stand for? Duplicate. God, that's a good name. All right. Awesome. So something like that. Now we have the actual characters in pointer name, which we'll need at some point. So we have. Don't forget the null. Right. So I'm saying I left it off there when I malloced. You probably need to add it to this, but I'm not worrying about the null terminator E in the back.
I'm pretty sure you don't need to add it because it's actually tagged on ID. So when you pass it on the string copy, you should add it. Okay.
I agree, but I just wasn't like, so my worry was, so yeah, I mean, the null terminator is on ID, right? That's how it's a character pointer. And I was like, I don't really know where string copy ends and begins. I don't know if it copies up until the null pointer or past, like right before it. I just didn't know. So to be safe, I thought I'd mention it in case your programs go haywire. But this probably is okay, right? It'll copy through the null. Awesome. So we don't need to worry about that. So we still need to, so we have, I mean, if we think in our add, this is taken care of, right? We have, we've mallocked it, we've assigned it a value and whatnot, right? So I guess we'll move on to the symbol value, right? So we might want to say something like pointer symbol value equals value, creatively named by Brian. Okay. So thank God we don't have to do any more string copies. We don't have to do an integer copy. Yes?
In the malloc, do you have to, I think you have to do size up and then times the length of the string. I don't think if you just do size up, it'll just do the size of the char.
Oh, yeah.
You're right.
Because that's the size of a pointer.
Yeah, that's the size of a pointer. So what's awesome is I wrote it in my notes correctly, but I get perpetually lazier as this lecture goes on, so forgive me. So yeah, this is Sterling of, ID, right? Times char. Huh? Size of chart. Right. Yeah. Huh?
Size of char is 1 anyway.
Right. So we don't need to worry about that. So this is actually, I think, where the +1 that I'd written down comes in, because string length of ID doesn't include the null terminator. So at this point, we do need the 1, and that's why I'm slightly less crazy than I thought I was. Yes, I did. All right. Does that make sense? Yes, new problem.
That's not going to work.
It will not work.
You're going to get the size of the string length ID +1, but that's the type of string length that you're going to get the size of. It would just be string length ID +1 times size of char, or which is 1, or just string length ID +1. Yeah, you need to move a parentheses.
I need to move the ID here.
Huh?
I need to move this parenthesis to the right.
Yeah, the word size of it will take the integer and then take the size
Oh.
of the integer instead.
Yeah, otherwise you're just going to get like 2.
Right. So I think that I originally wrote it like that.
Well, we can size up ID star maybe. That'll give you 3.
ID star. Okay.
Then you're going to get 5 of it.
Okay, so you're going to say that?
Yeah.
All right, cool. No, damn it, that was it. There we go, saying things I shouldn't say. Apologies. All right, so let's not point out any more mistakes I have with that, and let's just assume it works. And when you come to when you try to write this and you get 7 syntax errors, you and GCC can work it out. And don't come to my office hour about it, because I never want to think about malloc ever again. I hate malloc so much. Okay, so on to things that aren't mallocked. So we need some sort of next, right? So we've taken care of symbol name, we've taken care of symbol value, and we need next, right? So maybe we'll have something like pointer next is what? Is what? Null?
Oh, wait, we're adding at the head? Oh, never mind. That's the best place to add. It's the easiest.
It is the easiest. Okay, Keith? Table. Good. That's what we called it, right? All right. Table. It's possible you'll need to do some sort of cast in there, but hopefully C will take care of it for you. If that gets angry, then cast that to a symbol table entry star struct.
I think you need ampersand before table.
Table is a pointer. Table is a pointer to a symbol entry. I think that an ampersand would be bad here. I make no promises, as always. We've been over this. So I hilariously stated that I was bad at coding early on, right, when I was sitting here at this computer coding something for you guys. And then I don't remember who it was, but someone's like, yeah, you really are bad at coding. And I was like, ah. It was a joke, and now it hurts. All right, so, yeah, I don't think you need an ampersand. Yeah, so that should be good, right? So now then this guy's kind of, let's assume that we magically already had, that's probably too small, x with value 1.3, right? That was our symbol table at that point. 1 second. And then we're adding something to it, so we allocate this new symbol table, and it's y with 5.7, and this guy's next was null, right? And his next is that. It looks something like that. Will? It's a fantastic idea, but forget it. No, that's the next line. Yeah. All right. So we also want to say that table equals pointer, right? And anything else?
At some point, you probably need a closing brace.
Closing brace. Good. I'll argue that we need one other thing that I'll just write for you, because who cares? It's return, right? Pointer. So that is ideally add in all of its glory. Just take a picture of it. So I'm about to erase symbol entry struct on the right and write get over there. Is everyone okay with that?
Almost.
Almost.
Yep, I'm okay with it.
Now we're good.